Hello SL2. Today's topic is another application of derivatives. We're going to be looking at economic models today. Therefore, our essential question is how can I apply my knowledge of derivatives to business? So we're going to be jumping right into some definitions. The first thing is to think about the summary of what a cost function is. And if C of X is the cost in dollars and our X is the amount of items produced, then we can start by looking just at a graph of what that would mean. So the first idea is just to think about when a company is starting up a new product, they always have to have some startup costs. So our cost of the zero item is actually above zero. There will be some startup cost. Then as our items of X increase, you will have this curve right here is just an example of what a C of X function could look like. So here in the beginning the cost is going up, but at some point it might go down and then it goes up again. The more items you're producing might cause another reason for it to increase. So this is just a graph, and this is one of the best reasons you'll see in the economic world. You'll see these cost functions being used when you graduate from high school and go to college. So this is for me, pretty exciting to see another application similar to like optimization. These are real life examples. So let's get into the calculus. What are people doing when they're analyzing these graphs? And the first definition you need to know is that marginal cost. This word marginal cost, whenever you see that, you're going to immediately think about the instantaneous rate of change in cost with respect to the number of items made. So anytime you see this instantaneous rate of change, you're thinking about the first derivative. So if we go back to our graph here, and our first derivative, if we found that here, this would show that this part is, that's right, is an increasing, and then at some point here there would be, the derivative would be 0, and then it would increase again the more cost. So the marginal cost is the slope of the tangent line at each x value. Or another way again to think about it is the rate of the change, the instantaneous rate of change in cost. Okay, another word that you'll need to know is thinking about an average cost of an item. So an average cost is a little bit different than a marginal cost. We will see the average cost of item when X of them are made. So each of our average costs, that function, you'll have to take the original cost function and divide it by X. Because at each point along here, let's look at this point in particular. So at that point here, this would be the cost, the C of X. And we would want to find our average cost. So you would actually find from the cost it would to make these number of items, you would actually have to draw a line from here to here and find that slope. To find that would be the cost that it would take to make these number of items, this X here. Okay, so let me say that again one more time here. So at this point, this exact point here, that would be the X number of items, and we could say it's 10 or 50 or however many items, depending on what you're making. It would, at that value, the cost of making that item would be your Y there. And to find that average cost of that from making 0 to this value of these X numbers, you would have to find the slope of this line here, or change in Y over change in X. So that is what we're going to be finding with our average cost. When it gets to here, you'll see that it'll be a different cost. So the initial average cost is much steeper, but then up here you'll see, if we use a different color and we drew a line, you could see the average cost would be less, and that's a rough graph of my line there. So that slope from between here and there of this value would be with some point in this area, you could see that it would minimize. And if you think about all we've been learning about this unit, how can we find where it minimizes, where the cost would minimize? And that's right at this point here would seem to make sense, wherever it would level out here, and where our average cost equals our marginal cost, that would appear to be a minimum, a possible minimum. So let's look at that, and let's do this as kind of a check using our knowledge. So that would make sense if you think just about costs in general and anything that you might be interested in making or buying. So let's just go ahead and easily check it using calculus. So if we know our formula here, I can just use the quotient rule to take the derivative, and to find any kind of minimum, then we would take the derivative and set equal to 0. So let's just go ahead and do that. Let's take we want to find the minimum of average cost. So let's take the derivative. And we'll have to use the quotient rule because we have a cost function divided by x. So if u is my cost function, remember our quotient is our derivative of u times v minus u times the derivative of v over v squared. So I'll start off with my derivative of u, which would be in this case the derivative of my cost function, times my v, which is my denominator, so times x, and then I'm going to subtract my derivative of v. In this case, v is equal to x, and the derivative of x would be 1, times my u, which in this case is the cost function. And then this would be all over x squared. That would be the v squared. So anytime we're trying to find the minimum cost, we're going to set our derivative to 0. So in this case, we'll set this equal to 0. And again, when we have a fraction, a rational expression, we will just worry about the numerator equals 0. So we have our derivative of our cost function times x minus our cost function equals 0. So how do we make this 0? And that would be our derivative of x times x equal our cost function. If we just divide both sides by x, we'll see what we originally thought is the case. We'll find this becomes our marginal cost, right? Our derivative of x is called our marginal cost, And then here is our original definition of our average cost. So we just proved it, that our average cost, when we define a minimum, would have to equal our marginal cost. So remember, the derivative is our marginal cost, and our average cost is our cost function divided by x. Okay, let's try a problem here. So our first problem, we have a cost function where this is our cost function. So again, just finding our average cost function, I'm going to just keep writing the definition out. So our average cost is the cost function divided by x, and I will take this entire thing and divide by x. So if we divide the entire thing by x, and I'll just put a visual here. So each item is being divided by x. So this term would be 0.00013 squared. Here it would simplify to 0.002x. Here would be 5x divided by x would be 5. And then our last item will be 2200 divided by x. And that is our average cost function. So that would answer that question. Okay, so we would continue to box that. And our next question is asking, when would the average cost be minimized? So that would be going back to our initial idea. Our average cost is minimized when it equals the marginal cost. So we want to find the derivative, the marginal cost, because we want to find when the average cost is equal to that first derivative, the marginal cost. So let's find the derivative of the cost function, and we'll just use the power rule here. And using the power rule, we'll have 3 times and our 0.00013, which would make it 0.0039x squared. And then we would have 0.004x plus 5. So we want to find when the derivative of the cost function, the marginal cost, is equal to the average cost. So to me, the fastest way will be using our calculator. So let me pull that up for you. And what I did was just plug both of these into my TI-84 Plus. So if you need to pause the video, go ahead and do that and come back. Okay, so notice how I put this rational expression, part of my function here, in with parentheses. You will need to do that. And what I'm going to be doing is graphing. We have our average cost in my y1, and then I have my derivative, my marginal cost, in y2. When I go to graph it, you'll notice that you get a funky thing. So really important that when you're doing these, you need to change your windows. So let's zoom them out. Let's change them all the way out here. And change our scale a little bit, and as you can see, it's starting to come up here. And now you can see where my graph is going to intersect, and we'll pick up here.